Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition.
Hello, everyone, and welcome to our Manufacturing Lunch and Learn, with this presentation brought to you by Open Mind Technologies. I'm Elizabeth Modick, Editorial Director for GIE Media's Manufacturing Group of Publications, and I will be your moderator. Kevin Lewis, an Account Manager for Open Mind Technologies USA, will be discussing leveraging CAM for ultrasonic knife cutting of composites and honeycomb materials. Kevin will cover a new approach showing how programming ultrasonic knife cutting with Hypermill is easily accomplished and provides NC code simulation to reliably bring challenging 6-axis output to the machine. So with that, I'm handing the controls over to Kevin.
Thank you very much for the kind introduction. Again, my name is Kevin Lewis. I'm Account Manager for Open Mind Technologies. I'm based in Scottsdale, Arizona, and I cover much of the west of the United States. Today, we're going to talk a little bit about ultrasonic knife cutting. The order of presentation will be a little bit about, our company Open Mind, why we're talking about ultrasonic knife cutting, and how is it done today, and what's the solution that we created to make this a little easier and more profitable, more importantly. First off, about my company, Open Mind. There is a little bit of confusion in the marketplace where Open Mind and Hypermill are used interchangeably. So just to clarify, Open Mind is the company, and Open Mind really represents the people, and Hypermill is the product. 100% of our efforts go towards Hypermill and its related products and services with the singular goal of helping our customers make machine parts at a higher profit. 380 employees across the globe bring to our customers proven manufacturing results, and we deliver these results through a combination of experience, software intelligence, automation, and innovation that provide a meaningful difference to our customers' bottom line. The technology inside of Hypermill is developed by Open Mind, not third parties, and this allows us to react quickly to changes in manufacturing technology. A good example of this would be a product that we created specifically for ultrasonic knife cutting, ironically enough. Now, if you're familiar with our company Open Mind or our product Hypermill, you've probably heard we are excellent for 5-axis machining and considered innovators in CAM technology. And while this is a wonderful reputation to have, sometimes it can have a downside. When you're really good at something, people tend to think that this is the only thing that you're good at. And so let's just use a moment to clarify. Hypermill is not only for 5-axis machining. We offer a range of products for manufacturing that can be used as a tactical point solution or as a hub of manufacturing that will position your company for velocity and growth in the coming decades. Why ultrasonic knife cutting? Well, as we move towards a greener future and more fuel efficient travel, lightweight materials are a key factor in solutions that save energy due to their superior physical properties. They have strength, stiffness, fatigue resistance, low density, corrosion resistance, and of course, they're lightweight. Traditionally, these have been used in aircrafts, of course, aerospace structures and rockets, jet engines, and propellers. These traditional markets were perhaps not so worried about the cost of a material or the expense of shaping the material for their use. They were only concerned with the benefit. So these ideas are not new. They're well tested in industry, but they're now being approached by, good ideas spread. So if you believe in capitalism and the democratizing power of technology, the use of these lightweight materials will expand in the future. In fact, they're doing so today. These materials are moving towards non-aerospace applications such as wind turbines, electric vehicles, consumer goods. The cost of materials is falling. The expense of manufacturing them is being reduced. The terms Moore's law is probably thrown around too often. I'm not trying to say that the cost of these materials and shaping them will be cut in half in a 2-year period, but they are coming down and will continue to come down. It's also important to recognize that knife cutting was once a domain of specialist machine tools and specialist manufacturing companies, but now universal machine tools are being used to great impact in shaping these advanced materials. Also, an interesting trend is that top-line aerospace companies are now moving the cutting of advanced materials to their supplier base. And there's opportunity and profit to be made in overcoming challenges on your client's behalf. Now, historically, often these materials have been milled using a cutting tool similar to what is shown on the left. Uh, Sharp edges in the bottom of the cutting tool cut the material, and a series of teeth above that cutting edge rip away material above the cut. Well, what's wrong with that? Well, as you can see in the picture on the right, those are not very clean edges where the material is torn away. They have to deal with pollution from dust. There is a lot of stress in the work holding from the force of this cutting tool moving through the material. And, finally, it can be limiting in the shapes that can be made. What's the solution to this? Well, solution is ultrasonic cutting technology. These materials can be cut with a knife, and to oversimplify what is actually a remarkable and complex process, sound waves are converted to a micro oscillation of the cutting tool. If you're a simpleton like me, this is what I think of. There's less cutting pressure required because the blade is moving, and it results in a cleaner cut. Ultrasonic knife cutting is the ideal process for these advanced materials. It's fast, it's accurate, it reduces dust, it eases work holding, improves cutting tool life, and makes a better result. Uh, what's not to love about this process? Well, the first challenge is represented by the machine that's typically used in knife cutting applications due to the size of the parts. We would call this machine a fork head or a head kinematic because both the rotating and tilting axis are located in the head of the machine. Uh, the rotational axis usually has a mechanical limitation. So unlike a traditional trunnion machine where rotating and tilting axes are in the table, this one is going to be limited to about 360 degrees of movement, typically a little bit more. If this limitation is reached or encountered during a machining operation, the head of the machine must retract, unwind, and reapproach the part. Generally it's considered, undesirable in any situation, and certainly so when doing ultrasonic knife cutting. Additional challenges represented here are the head machine is asymmetric. So it gives some strange collision conditions in some cases. Also, the tilting axis is equal in both directions. So on a machine like this, maybe the tilting axis moves 110 degrees in both directions. And if you have experience with 5-axis machining, or perhaps have spherical geometry as a hobby, you understand that there are two solutions available for each position that the machine that we'd like to put the cutting tool in. So like, for example, a rotational axis of 0 and a tilting axis of +10 puts the cutting tool in the exact same position as a rotational axis 180 and a tilt of -10. Uh, these factors put a lot of pressure on the programmer to understand his machine, and the cutting operation has to be completed. He, the programmer has to be predictive of what the machine is going to do and eliminate any possibility to encounter an axis limit, and also deal with the strange collision conditions represented by an by an asymmetrical head. Using a machine tool like this is challenging enough in 5-axis. Of course, knife cutting requires the use of a 6-axis, the spindle, so that the bevel of the knife can be properly aligned to the surface being cut, representing an even greater challenge. So what's being done in industry today? I'd like to just start with a couple of disclaimers. I don't pretend to be an expert on the process created and followed by other people. So what did I do to get an understanding of what's happening in the industry today? I've conducted interviews with clients. I've talked to employees of machine tool manufacturers. I've read a white paper on creating NC instruction for ultrasonic knife cutting, and in every case, this is the process that was described. So first off, we use a CAM software to orient the cutting tool for 5-axis motion. It is typically done using a swarf cut, and a swarf cut just means we're trying to align a cylinder to a surface, and that results in a 5-axis motion. Then we go to a post-processor. Post-processor is used to generate the NC file, the specific instruction for the machine tool in the format required by the machine tool's control. At that point, some manual effort is invested. Programmer would be responsible for creating alignment for the 6th axis in some way. And typically this is a manual effort that they're inserting or adjusting code to orient that 6th axis. Again, as there are 2 solutions for every cutting tool orientation, there's some manual effort for the programmer to choose which of the 2 orientations is better, which is collision free and also is in the sweet spot of the machine tool movement so that no rewind is encountered. And then finally, NC verification software. These materials are expensive, so they're going to put as much as you can before you put a cutting tool to the material to make sure no material is wasted. And if this wasn't enough, NC programming is an iterative process, meaning it's going to be done and again and again and again. You're not going to get things right in the first try, so you're going to, try, test, iterate, do it again until you come up with an optimal program. And every single iteration is going to follow the same process shown here. Efforts are required with every single iteration. You start at 1, you end at 5, and there's no deviation. Also interesting here is that in this process, you're probably dealing with 3 different software packages. One for CAM, one for the post-processor, and one for NC verification. And these are provided by 3 different vendors, typically. And the question becomes, who do you contact when things go sideways? How do you direct a change in behavior when you're working with a large team like that? And I guess that's why we saw an opportunity in creating a specific solution for creating the NC instruction for ultrasonic knife cutting applications. So we created a very specific module for knife cutting, and then a key technology here is virtual machine and optimizer. Virtual machine is NC code based verification built into Hypermill. Optimizers there to control some advanced behavior. It's going to align the 6th axis to the orientation. So the orientation of the knife is correct during cutting. It's going to understand the machine kinematics so a rewind isn't encountered during a cut, if at all possible. You might call this a pre-wind. We're going to eliminate safe position movements by moving directly from the end of one cut to the beginning of the next while pre-positioning the head of the machine to eliminate those rewinds. And then, like I said, we also created a module that was specific for knife cutting. The first challenge here is that CAM software historically uses rotating tools, of course. They're all cylindrical in shape or some sort of rotational body. In this case, we're going to use a knife, which is, well, it's not a cylindrical or rotating shape. So you have to be able to properly describe a knife. What is the angle from the center line? What does the bevel look like? And if you're not sure what a bevel is, it's just the 2 flat points, 2 flat sides of a knife that come together to make the cutting edge. The tip of these things is not pointed, it's actually flat in many cases. So, what does a flat part look like? And there's 2 sides to this that can be used. Which cutting side are you actually going to use? A or B? The software allow you to define a default lead angle or reduced feed rate for when you're entering the material, so you're not knocking it loose from the work holding. And then, quite often this is, something that the cutting tool manufacturers would describe, is that you actually don't want the bevel of the knife to rest directly on the edge to be cut, you want some additional rotational angle so that only the leading edge of the knife is actually in contact with the surface being cut, and the bevel of the knife is just slightly away from it. Now, again, we talked a little bit about Optimizer, but it's important for you to understand that virtual machine and NC Optimizer are not a post processor. So this is not a post processor. Speaking in a general sense, post processors are not particularly intelligent pieces of software. They exist to translate, this into that, what you see in the CAM software into instructions for the machine. And, I can't really say that technology in use there has changed substantially in decades. Virtual Machine and Optimizer is a software solution created to generate an NC file for a target machine tool. Virtual Machine Optimizer will understand the kinematics of the machine tool and mechanical limitations, deliver a safe, efficient instruction to the target machine. In the case of knife cutting, it'll automatically align the knife. It will make any decisions required on which of the two solutions will be used so that a rewind is avoided, and it will eliminate safe position moves. Generally speaking, it behaves how you would think software should behave in 2023, and that makes it remarkable. A virtual machine itself is NC-based simulation, and there are some corollaries to this you know, in the marketplace today. The value that you see in virtual machine NC code-based simulation will match exactly the values of the machine tool being run. When you do a comparison of virtual machine and the machine tool's control unit, the values are going to match. That being said, being inside of the host CAM system offers some distinct advantages. The advantages come in terms of speed as you're iterating, but also there's some advantage in understanding the programmer intent. If you think of cutting with a negative allowance, the programmer is purposely violating the CAD model of the machine tool or CAD model of the project that he is intending to cut. In an external simulation package, this would be probably viewed as a collision or something negative, but because we're inside of the host CAM system, we understand the programmer's intent was to do this and would not flag it as a collision. So I asked one of my colleagues to just knock up an example of what programming ultrasonic knife cutting would look like in Hypermill. And this is what he came up with. So typically programming for ultrasonic knife cutting inside of Hypermill is programmed very similar to a SWRF. In this case, we're using SWRF using two curves. In the interest of brevity of this demonstration, he has already recreated the curves that are being used, but this, gives me an opportunity to say, there is a CAD component to Hypermill, and being able to extract these curves and modify them to suit the needs of the programmer is a very easy task. Once programming is done, he's doing an internal simulation just to make sure that he generally has this done. And again, at this point, this is only 5-axis motion. Inside the knife cutting module itself, he's described the knife, which side of the knife he's going to use for cut, any sort of reduced feed rate he requires for entry into the material, a default lead angle. So he might say, by default, I would like to lead this forward by, 10, 15 degrees. And in addition, he could use synchronization lines to control the attitude of the knife as it's moving through the material. Again, we're going to do an internal simulation to make sure that he has this, about what he wants. And at this point, he's going to generate the NC file so that we can do a simulation. Now, at this point, I would like to just kind of pause the recording for a moment because this is where some of the interesting stuff is going to happen. This is where Optimizer behaves. So we've generated the NC file, and then Optimizer gets involved to orient the knife. So control the 6-axis to make sure that the angle of the knife matches the programmer's intent. It's also going to, make those decisions on which of the two solutions that we want to do. So it's going to pre-wind to make sure that no axis limit is going to be encountered. And then it is going to do some uh, we'll call it linking behavior. How do I move from the end of one cut to the beginning of the next in an efficient manner, while also doing that pre-wind behavior to make sure that a rewind is not encountered during a second cut. And that is optimizer at work. At the point that optimizer is done, the project is loaded into virtual machine. And as you can see during the simulation, the entire movement of the machine tool is simulated. And here you can see it's linking behavior. We'll also pre-winding to reorient that head to make sure it's not going to hit a physical limitation and off rewind while it's right in the middle of a cut. Now, because as we discussed, CAM programming is an iterative process. It's just not something you get right in the first try, and unless you're doing something exceedingly simple. And so I just asked them to add some additional cuts here to just make a demonstration of what an iteration might look like. How do we move through a project and keep on adding individual machining jobs until the project is complete. Again, so he's added another swarf cut. He's going to do a quick internal simulation and then generate the NC file. Again, optimizer is behaving to orient the 6-axis, eliminate safe position moves, get the head in the proper orientation to make sure that a limit is not encountered or rewind is not required while it's in the middle of a cut. And again, this is what the simulation looks like. There are a lot of information available to the programmer on the screen here. Again, actual machine coordinates for the machine tool are visible there, as well as the NC file that he is simulating. And there's also some analysis functions available within virtual machine as well for the programmer. And this video is going to show you just a bit about what this same project looks like when it's on the machine tool. So here you've seen already that's virtual machine and optimizer, and here is the knife moving through the material. Now, in addition to being able to program for 6-axis applications using ultrasonic knife, of course, we can do programming using these rotational tools, rotating tools. You can see here what we're talking about as far as the additional cutting tool pressure and the dust as a result of using these cutting tools. This is a different style of ultrasonic knife that's used for finishing applications. And here you can see how clean the cuts are when using the ultrasonic knife. And so that is what we had to share for you on the process to be able to make ultrasonic knife cutting or more approachable, more profitable, and just possible for your company.
Kevin, thank you for the presentation. And we do have time for some questions. The first
Great.
one, does OpenMind just provide the software, or do you provide the ultrasonic cutting head as well?
We are part of the strength of OpenMind is our 100% focus on software and solutions. So we're completely focused on CAM and software, its related services, training, additional development, and no, the machine tools and ultrasonic heads and cutting tools are all made by other vendors that we do have a relationship with.
Great. And another question came in. Can I implement an ultrasonic knife cutting process on my current 5-axis machining center?
Yes, you can. And traditionally, like I said, these were the domain of specialist machine tools, but even in the video that we show, that is a 5-axis machine tool that was equipped with a aftermarket ultrasonic head and knife. And so this absolutely, can be done provided you have a big enough machine tool.
That's good to know. Now, can you tell me, does Virtual Machine Optimizer hold benefit for manufacturing applications other than knife cutting?
Yeah, I would say that Virtual Machine Optimizer have a huge benefit. First and foremost, it reduces pressure on the programmer. It just allows him to be 100% assured that he's creating a safe and efficient program for his machine tool. But these linking behaviors and ability to reduce cutting time on the machine tool within a manufacturing facility, this is like free money. It's the most efficient machine tool movement that you can get, and it doesn't cost any effort on the part of the programmer. He doesn't have to do anything to enjoy the benefit. Um, I'd also say that Virtual Machine Optimizer can be a real key to being able to run your machine tools unattended. Um, we recently had a customer say to us that has been using Virtual Machine Optimizer for I'd say about 18 months, and said that they're just so comfortable with it, they no longer stand by the machine. And in fact, if the boss sees them near the machine, he shoos them away and asks them to find something to do that holds more benefit. In our business, the daytime is used for machine tool payments, and the nighttime is for company profit. And if you're not effectively using the machine tools overnight, then you're just leaving a lot of money on the table.
So true. And it looks like we got time for one more question. Can ultrasonic knife cutting be used in roughing?
Uh, yeah, that's a good question. Yeah, it is being used in roughing, and I wish I had an example of it to share. What this looks like is that it's almost like the knife is used to score the material. So it's doing these swerve cuts in 3D across a large surface area, and it's trying to create almost like a V shape of material that can be either lifted out of the part before additional roughing operations or left in place. And because it's not affixed the entire part, when you come along with a round tool like that, finishing cutter or rotating tool, it's more easily to push that material out of the way for a roughing operation. So it can be much more efficient for removing material from a large area.
Thank you, Kevin, for the presentation and taking the questions.
You can find more Lunch and Learns plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcasts, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.